All right, thank you, Kevin.
Yep, thank you for the introduction, Anthony. So as Anthony mentioned, I am a coach and coder and process coach and technical coach and et cetera, at Industrial Logic. I guess it's over 15 years experience now. I started my my journey with a team doing XP that was a lot of fun, and then have tried to bring that feel back to all of the places that I've worked. So it's been a good time. I added this this question thing, slides.app.google, et cetera. I've never used it before, so I have no idea how it's going to work. But if you feel like asking questions there, feel free to. If you would rather ask questions by just speaking up, you're welcome to do that as well. I am happy to be interrupted. And this will be about 30 to 40 minutes or so if there are no interruptions. So I think we've got a little bit more time than that. So feel free to jump in if you've got anything. Cool. So, oh, and you can find more about me at either industriallogic.com or at gemsoftware.co is my site. And I'm going to throw out a link to another site a little bit later where I write a little bit more about this, along with Mike Bowler, actually. So we've been working on this together quite a bit. Cool. So I'm going to talk today about flow metrics for predictability and forecasting. So let's talk a little bit about what the agenda is. First, I'm going to introduce what forecasting is. Like, why do we do it? What is it? How does it work? In doing that, we're going to introduce a couple of the flow metrics and then a couple of models for forecasting, some ways that you can actually do the forecasting. And then we're going to talk about a few other flow metrics and then how you can use these ideas and these concepts to actually improve your predictability, right? Being able to say when we might be done with something is one question, and then the next question might be, how can we get better at saying when we're going to be done with something, right? How can we be better and more accurate in our predictions? Cool. So when will it be done? This is one of the most frustrating questions that most teams are asked. It's often really difficult to answer. You know, your manager might come and ask you this, and your response might be, well, in Agile, there are no dates, right? You know, that there's that idea that we don't commit to dates. We can't have fixed time things in Agile. Well, the reality of the world is that there's a lot of really good reasons to make forecasts, right? We have marketing plans that need to be put together. We have business projections. We have dependent and related work that we have to talk about, right? There's things that need to happen at the same time in order for them to be valuable. And we want to be able to do this effectively, right? We want to be able to enable the businesses that we work at and the teams that we're working with to be able to do all of this work effectively so that things come together in the right way. So how do we do that? So in like historically, the way we've done that is we've taken a magnifying glass and tried to look really closely at the thing that we're doing, right? We try to spend a whole lot of time breaking things down into little small pieces and then estimating each of those pieces, adding it all up and coming up with an estimate, right? Even worse than this, often managers do this instead of the teams, right? The managers are asked to do it for their teams or something along those lines, or maybe the teams push back and the manager's like, oh, well, I want to enable the teams. So maybe I'll just come up with a date. And that tends to not work, right? So what often ends up happening is we take these, you know, story points or ideal days and we convert that into a delivery date somehow. And then we add a fudge factor, right? We say, well, let's add 15 to 20%, right? And we'll probably be okay as long as we add that. And that'll cover for all of our risks. So what happens when we get these wrong? Because we inevitably get them wrong because we are really bad at seeing the future. We get a bigger magnifying glass, right? And we spend more time, and we think that if we look more closely that we're going to get better at it magically. The problem is that we're really just inordinately bad at this, right? We're like really, really bad at estimating stuff and seeing the future in this way. We often assume best case scenarios. We assume the work is going to go smoothly, that all of our dependencies are going to be met, and we only look at the things that we're in control of, right? And that, unfortunately, is not a very useful way to do forecasting, right? To forecast when work is going to be done. We often assume that we're going to be fully dedicated instead of being split in multiple directions, which we inevitably are. Like I said, the sort of most important part of this is that we only account for our work, and we don't worry about the system effects of the way that an organization operates. So how can we do this and still be able to answer that initial question, when will it be done? How can we account for all of this stuff and still be able to answer that question? So this is where forecasting comes in. Luckily for us, forecasting is something that has been really important to humans. One of the best examples of this is in hurricanes, right? Hurricanes are some of the most damaging phenomena that's out there. It causes millions of dollars, billions of dollars of damage every year. And we are able to forecast where hurricanes go, but it's a really, really complicated system. So this is what a hurricane forecast looks like. Let's see if I can play this video. So, oh, no, this is not the video. I'll show a video in a minute. So this is what a hurricane forecast looks like. The first thing is that there's a cone, right? That white cone is the range of probable paths of the storm, right? There's 60 to 70% of the time, the center of the storm is going to fall inside of that cone. So there's a range that's involved in this. It's not 100% certain because, you know, in systems this complicated, we can't determine these things with 100% probability. This is a 60 to 70% chance in the case of hurricanes. This is what that sort of caveat looks like from the NOAA. So the forecast that we use to build this, the process that we use to build these forecasts looks something like this. We simulate the path of the hurricane many times, right? Thousands of times we simulate the path of the hurricane. Based on all of these unknowns, all of the history that we have, all of the factors that go into it, and we draw all of these paths. And like I said, right, 60 to 70% of those paths end up inside of the cone. So each of those lines is a possible path that the hurricane is going to take, and they do some math to figure out how likely is it that it's going to end up in different places. What else happens when we do a hurricane forecast? So this is how a hurricane forecast generally sort of evolves, right? So this is Hurricane Ike back in 2008. Some of you might remember that. It was a pretty damaging hurricane, right? So you'll notice that the hurricane forecast is being updated frequently. So every about 6 hours while the hurricane is out to sea, they're updating the forecast. And if they were to stop updating the forecast, we'll see when it starts over, if it starts over. It looks like it's going to go sort of hit Florida, right? And it's going to go maybe up the East Coast at that point. But they keep updating this forecast as they get new information, and they find out that, oh, it's actually going to hit Houston, right? The other thing that happens is that they do this more frequently when there's higher risk. So the closer that it gets to landfall, they start doing the forecast more frequently. So they do it, like I said, every about 6 hours when it's out to sea, and every 3 hours when it gets closer to land. So the forecast is based on new up-to-date information. Let's see. Why did that restart? So those are some of the principles that they use for forecasting hurricanes. So how can we use this for knowledge work? How can we apply those principles to this idea of forecasting for knowledge work? So the question that we asked at the beginning was, when will it be done? When you're thinking about this question, there's actually sort of two different forms of this question. So it can either be one thing or it can be multiple things. And the way that we forecast them is a little bit different depending on what we're talking about. So we're going to start by talking about one thing, mostly because it's a little bit more straightforward. Let me pull up a chat window because I don't know. Okay, cool. Yes, I will provide slides. They're available on my website as well at gemsoftware.co. So no problem providing those. Okay, so forecasting for knowledge work. Oh, I closed the chat window and that was a silly thing to do. Okay, so for one thing, what we want to use is cycle time. So this chart that you're looking at here is called a cycle time scatter plot. And what it's doing is each of these dots here is a thing that we finished. It's a piece of work, a card, a story, whatever you want to call it. It doesn't really matter. It is a piece of work that is finished. So the piece of work is put on the vertical axis based on how long it took to get done. So how long was it from when it started in our process to when it finished in our process? And on the horizontal axis based on the day that it was finished. So what you can do with this is you can define what we call a service level expectation. So a service level expectation is really simple. It's just this line that says 85% of the work is below that line, right? 85% of the things finished below that line. This is really straightforward, right? So we can say, based on history, if the things that we're working on in the future are similar to the things that we worked on in the past, there's about an 85% chance that it's going to take 16 days or less in this situation, right? So that's really all you've got to do for forecasting a single thing. I'm going to talk a little bit about how we can improve our forecasts and get more accurate a little bit later, but this is really the baseline, right? Is if you are tracking your cycle times, you can come up with this service level expectation and just say, 85% likelihood it's going to be 16 days or less. So we've got that range that's similar to the cone, and the confidence level, 85% of the time, right? Okay, so I mentioned that one thing was pretty straightforward. We're going to talk a little bit about multiple things now. So if we have multiple things, there's a few new pieces of information that we need. We need to have an idea of how many things there are. So we just need to sort of come up with a guess or a range of, in order to accomplish this goal, we think that we're going to need to do 50 to 100 things, or 175 to 225 things. The other piece of information that we have to track is throughput. So throughput is just the number of things that are finished in a period of time. So if that period of time is a day or a week, it doesn't really matter. We just need to start tracking throughput. The more granular you can get, the better you're going to be, but it doesn't really matter how granular you are. This works regardless. You will be more accurate if you're more granular. And what we do with this is we create a bunch of simulations. So this is very similar to the simulations that we showed you for the hurricane forecast. We just simulate burn downs. So what this is doing is it is randomly picking a throughput number and saying, you know what, on this day or on this week, we did that many things, right? So if we go back one slide, we might say, on this first day, we did 19 things. On the second day, we did 17 things. On the third day, we did 18 things. And it just randomly picks from that set of throughput samples and draws the burn down until we are finished, until we got everything done. What we do then is we can draw a line on this chart. So it's going to be somewhere around here, and say 85% of the time, we finish all of our things before that date, before 11/19/2021 in this case, right? So once again, we've got a range. We're going to say on or before 11/19, and we've got a confidence level, 85% of the time. So once again, this is how you forecast multiple things. It's still pretty straightforward, I think. There's a bunch of tools out there that can help you do this. This picture here is from a tool by Troy McGinnis. That's really just a spreadsheet that you can download off of his GitHub, and it will do all of these simulations for you. There are also tools that are plugins to Jira and to other things like that you can go out and find to do these. Or if you feel like writing some code or playing around in Excel, you can create the simulations yourself. They're relatively straightforward. Cool. So this is how we forecast multiple things. All right. So we introduced two of the flow metrics, throughput and cycle time. Throughput is the total number of work items completed during a unit of time, and cycle time is the amount of elapsed time it takes for a given work item to complete. So we talked so far about how to build a forecast, what the sort of process is to create the forecast, and we talked a little bit about a couple of flow metrics. Now we're going to introduce the last flow metric, and that is WIP, work in progress. Pretty straightforward again, the total number of items that are started and are not yet finished. All of these are pretty straightforward. So why are these the flow metrics? Where does that actually come from? It comes from a little thing called Little's Law. This was defined, I think it was back in like the 60s. And it was actually created to model the flow of shoppers in a grocery store. And all it's doing is modeling flow in some system, right? It's modeling the flow of things through a system. So this is a relation, there's a relationship between these things. Cycle time equals WIP divided by throughput, and those are all averages. And that is really important, because if you ever try to calculate Little's law, like try to say, you know, my WIP is X and my throughput is Y, so my cycle time is going to be Z. That's not going to work, because all of these things are averages, right? It just doesn't make sense to actually calculate these things. But the relationship between them is really important for us to talk about how we can improve our predictability. So, so far, are there any questions or any comments? We're going to talk about how to use all of this stuff to improve your predictability in a minute, but anything that I've said so far that you just don't believe or that doesn't make sense?
Can you give an example of this Little's law? Like, because with my thought, I'm thinking average work in progress, meaning average tickets that I need to complete over average tickets completed. Then what's that cycle time mean? Like, I'm just trying to have a grasp on that.
Yeah, so it means that, average work in progress is the average number of things that you actually have in your system at any given point, right? And your system can be defined in a lot of different ways. So it might be all the way from things that we have discovered that we need to do, or it might be things that the team has started or something along those lines, right? So if you're like I said, right, calculating this thing doesn't really make sense. But what this is saying is that if you on average have, say, 10 cards in progress, and on average, you get 2 cards done a day, then your average cycle time for all of those cards is going to be 5, right? That doesn't mean that any specific card is going to be 5 days. That means that on average, the cycle time of your cards is going to be 5 days. So you might have a card that is done in 10 days and a card that's done in 1 day. And if you take the average of those two, it's somewhere around 5. I'm not good at math in my head, but it should be somewhere around there, right? Does that make sense?
Yes, thank you very much. I needed somebody else to like put it out in words for me. Thank you.
No problem. And that's why it doesn't make sense to calculate these things, because it's not telling you exactly what throughput you should have or exactly what WIP you should have if you want to accomplish a certain cycle time. It's telling you what the average of these things are going to be. And we'll talk about how to make those averages closer to reality and a little bit about how to improve them as well in this next section.
And yeah, and then would you then use that number in the previous concept, or
in which previous concept?
Well, so in the previous where you were forecasting,
yep,
with the spreadsheet, does that average cycle time fit here?
It does not. We use actual numbers for this forecast. For this cycle time scatter plot, we use the actual cycle times. So it's really important to use actuals, because what we want to find is this 85% line, right? If we use the average cycle time is going to be right around this 50% line.
Yeah.
What that's saying, if you sort of think about it, is that half the time I'm going to be right and half the time I'm going to be wrong. Right? If I told you it's going to be 7 days or less, because that's what my average is, that means that half the time it's going to be 7 days or less, and half the time it's going to be more than that. Now, I don't know about you, but most of the folks that I work with aren't really happy with those odds, right?
Right.
85% is a pretty good estimate for most, like it's a pretty good stand-in for most of the time. And that's why we recommend starting with 85%. If you're in a higher risk situation, you might want to bump that up and go to 95% or something. If you're in a lower risk situation, maybe you can drop it down a little bit. So
then what does that average cycle time help me with? How do I use that number?
So the relationship is what's important. The actual number is not important. And let's jump into the predictability stuff, because I think this will all come together a little bit.
Sure. Thank you.
But yeah, it's the relationship between these things that matters. It's not that that any of the specific numbers matter. Okay, so let's talk about predictability, and if there are more questions about this, we can come back to that. Okay, so how do we improve predictability? What we need to do is make these numbers not change quite so much, right? And be a little bit closer, have the averages be closer to the actuals. So how do we do that? First is WIP. The reason that we're starting with WIP, even though WIP is not one of the values that's used in the forecasting, is because WIP is the only one of these things that we can explicitly control, right? We explicitly decide if we're going to let something enter our process or not, or if we're not going to let it enter our process. So we have to choose to move something into started, whatever that means. So because we can explicitly control it, that's the first one that we're going to use to try to improve our predictability. Yeah, so we need to explicitly control it. I said that already. All right, so typically how we do that is with WIP limits on a Kanban board, something along those lines. So we might have WIP limits of 2, 2, and 3 in columns A, B, and C. And we might say that, when something starts our process is when it transitions to A, and that's when we are able to forecast it, right? So the first question is, does it look like WIP is being managed in the system, right? Are we managing WIP well here? Not a trick question. Not yet, at least.
Yeah, looks fine.
Yeah, WIP is being managed well here, right? We've got 2 things in A, 2 things in B, and 3 things in C, and those are our WIP limits. So we're going to make a little change, and we're going to change our WIP limits a little bit. So we changed to our WIP limits being 2 things in A, 2 things in B, and 1 thing in C. Is our WIP being managed well here, right? We've got 3 things in C, but our WIP limit is 1.
No.
Still not a bad question. Right. No, it's not, right? We're over our WIP limit. We are not keeping WIP stable, is the words that I would use. So one more system, and what we did here is we changed the WIP limit in C to 6, and we have 3 things in C. Is WIP being managed well here? This is a little bit of a trick question.
Yeah, it's a huge it depends, isn't it?
Yeah, I was going to say, I mean, you'd have to look at I would think just relook at whether the 6 is the right WIP limit, maybe.
Yeah, we might look at that. But based on the way that we've defined our system,
It's okay then.
we are not managing WIP well.
Yeah.
Right. We're keeping WIP stable.
Mm-hmm.
And that stability is really key to improving our predictability. If we can keep our WIP stable, then our numbers start falling together and start meshing a little bit better. If our WIP is varying wildly, then we don't have a stable system, and we can't predict what's going to happen.
So that's why you'd want to relook at what your WIP limits are then, right?
Right. So we might want to redefine our system and say, you know what, our target is actually 3, not 6, because that's if that's what we normally have. Or you might want to define your WIP limits differently. So maybe you want to define the WIP in your system, the WIP targets in your system across the entire system rather than across individual columns or something like that. So you can look at playing with things like that. But the key here is that we want to keep our WIP stable, try to be at the same number, right? I try to define these rather than as WIP limits, as WIP targets, right? We want to be at this place, and that's how we know our system is stable. Does that make sense?
Yes.
Yeah.
Cool. Okay, so we talked about WIP targets a little bit. Okay, the next thing that we're going to talk about is cycle time, because that's the next thing that we can have a bit of an impact on. In order to talk about how we can make cycle time more stable, I'm going to introduce another metric, and that is work item age. So work item age is the elapsed time since a currently in progress work item was started. So if we look at this previous system, let's say it moved from to do to A on day 1 of our time period, and it is still in progress on day 4 of our time period, then that work item age is 4, right? It's been in progress for 4 days. So work item age, the elapsed time since a currently in progress work item was started. This chart that I'm showing you here is called a work item age chart. The reason we are going to focus on work item age rather than cycle time directly is because work item age is sort of a leading indicator of cycle time, right? On the day that our thing finishes, the work item age becomes the cycle time. And so if we can manage work item age, then we can affect what our cycle times will end up being. Cool. So this is the work item age chart. Each of the dots on this chart are, once again, representing a work item. And the height of the dot is representing how long it's been in progress. The column that it's in is representing the columns on your Kanban board, right? So this would be column A, B, C, D, E, whatever you call them. And what you'll see is these green, yellow, and orange sections here. So those sections are drawing the 85% line, but it's a little bit tricky to understand what it's doing. So this 85% line is the exact same one as we talked about earlier, right? It's at 16 days, and it takes us 16 days to finish 85% of our work, right? As we step back here, the top of this yellow line is the 85% line for when things exit dev done, right? So 85% of things exit dev done by day, I don't know, about 14 or so. And that means they move from dev done into testing by day 14. So as the things start exiting this green and yellow area, we start understanding that those things might be a problem, right? Those things are the things that might start pushing our cycle time up, that might break that 85% target that we had. So how can you use this? Well, you can use this during stand-up, right? Maybe we say, you know what, instead of talking about things from right to left, we're going to talk about the things that are in orange first, and then the things in yellow, and then the things in green. And what that's going to allow us to do is put this focus on the things that are going to be pushing our cycle time up. So indirectly, by controlling work item age, we can control cycle time. So we can start shifting the cycle time down by saying, you know what, this thing looks like it might be a problem eventually. Let's see if we can push it down back into the yellow by the time we get to dev active. And then hopefully we'll be in good shape again. This chart is a little bit difficult for some people to read. They like it. It seems to take a little bit of absorption to get it. Does this make sense to everyone? Does anyone have any questions about it?
Yeah, how did you derive, you might have said this and I missed it, how did you derive the different color zones?
Through tracking cycle time. So this is the trick with trying to do this manually is that you have to understand your cycle time as things leave each step in your process. In your work.
So it's basically based on historic data, so whatever your, yeah, okay, got it. All right,
yeah,
thank you.
Yeah, based on historical data.
I'll say that I currently use something like this in my current sprint cycles. We have 2 week sprint cycles, but we have an age limit where if a ticket is in a column, like in QA testing or in progress for more than 5 days, then the card turns red. And so that alerts us that, oh, something's too old that we were expecting.
Yeah, that's a good sort of approximation for something like this. You still don't know, like if it never got read in the previous columns, but it took like 4 days, and then we get to the last column and it's taking 5 days, then we still might have a problem. But it's a really good approximation for something like this. The tool that this is generated out of is called Actionable Agile. Unfortunately, it's not a free tool, and I don't know of any free tools that do this really well. I know that actually Mike Bowler, again, is working on some scripts that you could download, the Ruby scripts that do some of this for you. And he does offer them for free, I believe. So I don't know of any other free tools, though, that do this well. So, and
Kevin, is this from Daniel Vacanti?
This is from Dan Vacanti stuff, yeah.
Okay, yeah.
Yeah, I think, I don't know if he is an owner of Actionable Agile or if he's just a partner of some sort, but yeah, based on his books. Cool. Okay, so what about throughput? Well, remember I said that the relationship between these things is important. It's important because if we can control WIP and we can manage cycle time, then we don't really have to worry about throughput, right? If those two stay stable, then throughput's going to stay stable as well. And that's why this relationship is really cool, because we can't really do anything about throughput, right? Things are going to get done when they get done. We can't force them to get done. So if we can control WIP and control cycle time, then throughput's going to stay stable. And that's how we can sort of improve those forecasts, is by managing WIP and by managing cycle time. Cool. We're gonna well, I'll talk about this for a second. It's kind of a side note. One of the keys to these forecasts working is that you can't really throw out work, right? I'm not saying that you have to finish all of the work, and people often misunderstand that. But what I'm saying is that when you decide that you're not going to do something, that you're not going to, that this thing is no longer valuable, that it is too difficult and we shouldn't waste time continuing to work on it, et cetera, et cetera. When you decide that something isn't going to be done, you should mark it completed. And the reason for that is because it helps tie together your WIP, your cycle time, and your throughput, right? So all of those things depend on all of the pieces of work actually going all the way through your process. Like I said, I'm not saying that you should waste time actually finishing the work, like actually continuing to write the code, continuing to do the testing. But what I'm saying is that when you decide not to do that thing, that cycle time actually counts towards your forecasts in the cycle time scatter plot. And that throughput actually counts towards your throughput forecast using a Monte Carlo simulation. So by marking those cards as finished rather than just deleting them, you sort of preserve flow in the system and allow all of these things to stay stable. The other thing that this will give you is that it will give you a better understanding of when we decide not to do things, right? How can we figure that out earlier? If you tag this thing and say, you know, I decided not to do this, I decided not to do this, I decided not to do this, and we are able to go and look at all of those things, then you can have a conversation with your team about, you know, how could we have decided before we started it, maybe, that we weren't going to do it? Or how could we have decided in column A instead of in column D that we weren't going to do it? So this can give you a better understanding of what's going on in your team. So I am just about at the end. Let's see. So control WIP and manage the age of your work. That's the big picture here. I gave you some tools for actually creating the forecasts, and to improve your predictability, these are the two really important things. You control your WIP and you manage the age of work. Cool, thank you. Like I said, I am a Agile and technical coach, trainer, et cetera, at Industrial Logic. You can find more about me at either Gem Software or industriallogic.com, or you can go to improvingflow.com. That's where I write about some of this stuff along with Mike Bowler, and we've got some training that is offered up there as well. So feel free to take a look at that. Cool. Any final questions or comments or concerns? Anything that you just don't believe me? Like, no, Kevin, you're wrong.
No questions. This is
What?
such a hot topic. I figure there's got to be some.
Quite the opposite. It just makes me want to go out and play with some of this stuff.
Exactly. I was just thinking, I'm just thinking more than no questions. I'm just thinking what,
Yeah.
how to use some of this.
I feel as though there's a bunch of questions once I've got my hands on it that I'll probably ping you on.
Oh, I got one. What about like waiting on external stakeholders like clients and stuff? Like that's always a big one with me, where that like brings down brings up the age of work to be done.
Like a stuff on hold that you put on like an on hold.
Yeah, I'm like oh, this stuff is this data is missing because this partner won't send it to us for some reason.
Yeah.
And they're really delayed on looking into it.
Yep. Remember when I said at the beginning, when I talked about how we create forecasts, I said that we often only worry about our part of it and we don't worry about the system effects of actually getting a thing done. Those are the system effects. Those are the things that we ignore when we estimate. And this process, because we are actually tracking the cycle time, we're tracking the history of how long it takes us to get things done and how many things we get done. it allows us to take all of that stuff into account. And all of that happens, right? It's all real life. We can maybe do things to start managing it, right? So if we see that our cycle time is pushing up and we have a conversation about, this thing is getting old and it's because of our partner, maybe we can go and talk to that partner and come up with a better model for us to interact with them. Or maybe we can just let them know, hey, because of this, the work that we deliver to you is going to be unpredictable. Are you okay with that? Like, is that an okay thing? If it is, cool, right? So that is all stuff that like really actually happens and that we need to take into account as we're coming up with these forecasts. So one thing that I often see teams try to do, and I try to convince them not to, is that they don't count that on hold time in their cycle time. I'm like, but that's real time. Like, time doesn't stop because it's on hold. Like, you've got to count that, right? So avoid the temptation to do that.
Oh, on hold time means somebody outside the company is blocking the work, so not a problem.
Well, you could have an on hold with an dependency within the company too, though, if something happens.
That too.
That doesn't have to be just external.
That too. If another team is working on another project that's more priority. I get that.
Exactly, and that's something too.
Most of the time with me, if it's clients, it's like, oh, this client's not responding.
Mm-hmm.
Blame them.
What about the size of the thing? Would teams have a tendency to try to control work in progress or cycle time by changing the size of the things that they're working on?
Yeah, and that is probably okay, right? Because if our cycle times get pushed down because the thing is no longer as big, then, well, that's a good thing, right? We're delivering value sooner. So that's probably an okay thing as long as you are still focused on delivering value, right? As long as each of those pieces that are moving across your board are still valuable.
Yeah.
And that's actually sort of a natural sort of follow on from following a process similar to this. So one of the things that I recommend to teams is that, let's see, where am I? Trying to find the right slide. Sorry. I'll get there eventually. There we go. Is that when they're planning their work, all they really need to do is say, can we probably get it done in 16 days or less, right? Can we probably get it done below our 85% line? And if we probably can, then it's probably right sized, right? It's probably close enough to being the right size. And if we find out we were wrong, okay, we're always going to be wrong every once in a while. But what will happen as you do that is that your 85% line is going to shift down, right? Because if most of your things are below your 85% line, and then we get to like 90% of them are below your 85% line, well, that's no longer your 85% line, right? So it will just tend to shift things down if you use a process like that. And we're not making any like big sweeping changes. We're not making a big deal about it. All we're doing is asking that simple question, and teams are usually pretty comfortable answering it. Do you think you can get this done in this case, 16 days or less? Hopefully your cycle times are shorter than that, right? I would love to see every single team being 1 or 2 days or even less than that. That's not the reality in my experience. So I use numbers that are more realistic to most teams that I work with.
So then in that case, though, if your cycle time gets reduced, that 85% line is going to change. It's going to continually go down. Right?
Yeah,
so,
I mean, to a point, right? Eventually you're going to get to a point that it can't go down any further.
Yeah.
Sure. But well, I'll let you.
I guess I was getting at, you would want to almost redraw this graph on a regular basis because it will change, right? That 85% is going to change.
Yeah, exactly. Remember, as I was talking about the hurricane forecast, they update that forecast every 3 hours roughly.
Yeah.
We can probably update our forecasts just about as frequently, right? And If we find out that it's going to be lower, cool. We can have a conversation with our customers that it's going to be lower. If we find out that it's going to be higher, well, cool. We know earlier, and now we can have a conversation with our customers that it's going to be higher. But yeah, that is like updating this forecast on a regular basis is really critical, and it's really not too hard to do it every day, or possibly even more frequently than that.
Thank you for that.
Have you seen in Actionable Agile, there's also 2 Monte Carlo boards as well. One for, I think, how many you can get done in a certain amount of time, and you can set the parameters and how much time it will take you to get so many done, basically. Yeah. I like that better than the scatter plot. To me, the scatter plot I like to use just to look at, just to get a general idea of like where are the outliers, and what is with the outliers. Were there specific reasons for it, or did people just not move it along in Jira, or did it somehow it got forgotten about? But I like the Monte Carlo screens that they offer.
Yeah, and the Monte Carlo, this example here,
Oop, you're breaking up.
Oh, can you still hear me? Am I still here? Hello?
You're back.
Okay, I'm back.
So just
Yeah.
Repeat that last statement. I think we're good.
Okay. So yeah, so this forecast that we're talking about here is actually a Monte Carlo forecast, and I should probably have that on the slide somewhere, is what I was saying. But remember how I talked about these 2 forecasts are useful for different types of things. So when will it be done? It might be one thing, right? Maybe you've got a customer saying, I need this card like now. When are you going to have it done? And you can give them that forecast. Or it could be multiple things. So multiple things might be a project or something along those lines. And I talked about doing a multiple thing forecast in the context of, I have X number of things, when am I going to be done? But you can also sort of invert that and say, I have a release on X date, how many things can I get into it? So that's the 2 different Monte Carlo forecasts that Actionable Agile has built in. So they're sort of two sides of the same coin. Yeah.
One comment I wanted to make, can you go back, to this slide, people who said they wanted to get their hands on, if you go to that focusedobjective.com, you can download the Monte Carlo spreadsheet, basically that Troy provides for free on his website.
Yeah, and it's really an awesome tool. I kind of, Troy gives far too many things away for free, so I try to support him whenever I can. But this tool he's put a lot of time into, and I know a lot of other folks who have helped him out with it, and it's just a really cool tool. I can't recommend it enough.
Another great tool as part of Actionable Agile is cumulative flow diagram versus the standard one that you get in Jira. The one in Actionable Agile takes it to a much more detailed approach, and what I like to use it for is sort of the same as the scatter plot, not to focus so much on it because I think more is made out of it than it is, but I like to use it to figure out, well, where are the problems? Like, well, I mean, what happened that we didn't do so well last time? So if you sort of focus in on like a sprint or 2, you can usually figure that out. Also, if you're starting to tail off and maybe your flow isn't as good as it was, it's really good for that. So it kind of tells a story, to figure out, to root cause, well, what's going on? Like either we're not improving or we lost improvement or stuff like that.
Up, but Dave dropped out a little bit, but yeah, the cumulative flow diagram is really cool tool, and it can show in slightly different ways the relationship between all of these different things and how they actually like show up in a chart. I do introduce a cumulative flow diagram when I do like a 2-day class on this stuff. It's really useful, but it takes a little while to really get into it and make sure that it's being presented in a good way. But the other thing that I want to echo that Dave said is that, yeah, the cumulative flow diagram in Jira is kind of broken. It's not actually a cumulative flow diagram. So just be aware of its limitations if you're using it.
One place that I really like about the cumulative flow diagram is if you have a like an impeded or a weighting column, and then so when you look at that on the CFD in Actionable Agile, you'll start to see whatever you color is assigned to that, it'll get bigger, and then it will, it may be smaller, it may be bigger, and when it gets bigger, sort of shines a light on it, and then you start looking further into it, is why did it get bigger here? Like what happened during this time frame? So it's very helpful to shine a light on anomalies, basically.
Yeah. Yeah, and sometimes those anomalies are like perfectly reasonable, right? If you go and have a conversation about it, you might realize, oh, that was Thanksgiving. So yeah, of course we were waiting more on our clients, right? But sometimes they're not. Sometimes it's, oh, someone on another team left and we don't have a relationship with that team anymore. Oh, well, let's go fix that, right? Let's go talk to someone and build that relationship up.
Yeah, or vacation time, or somehow it just sat in there for too long. And then you go back to the person and say, why did it sit in here for this long? Oh, I forgot to move it. It sat there, but it helps to understand this, because then you can at least correct those issues. So going forward, it will help you to better track anomalies. Everybody really needs to do their part in Jira, because otherwise all this tracking stuff, it doesn't matter.
Mm-hmm.
I've had a coworker who's left.
Yeah, and
he's
the more
built an
often that you
entire
doing this stuff, and I use it.
entire platform for our company, and a couple of times we've had to reach out to him via Slack, and we're like, "Hey Sam, what does this do? How does this function again?" And he's always quick to respond. But yeah, I always say keeping up with relationships helps.
Yeah.
Okay, any other questions before we wrap today? All right, well, thank you so much, Kevin, for joining us today.
you.
Yeah. Thank
This is
you
a
all.
great topic, and thank you for helping to demystify it.
Yep. And if anyone comes up with questions later, I am always happy to have a conversation on LinkedIn or Twitter or wherever, however you want to get a hold of me. Thanks, Anthony. Thanks.
Awesome. Thank you.
Everyone.
Thank you.
Take care, everybody.
Thanks. Good stuff. Bye.